Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 4 of Linux Zero to Hero series, and in this episode, let's explore file permissions. So typically we will cover section 6 of our Linux course. Without wasting any time, let's try to understand what is file permissions and why is it required on a Linux server. To understand this better, let's quickly recap a concept that we learned in the previous episode, that is user management. So what did we learn about user management? We learned that Linux is a multi-user system. That means on a Linux server, you can set up multiple users and these users can share access to the server. But Abhishek, why multiple users need access to a Linux server? Is it a real-time thing? Yes. For example, if you take an organization called ORG and assume this organization deploys applications onto a Linux server, quite obviously, the developers of the organization, QE engineers, DevOps engineers, and multiple other engineers would need access to the Linux server. And you cannot grant all of them with the admin user and admin privileges, or maybe root user and the password. What a Linux administrator does is to create a unique user for everyone that requests access to the server. For example, if a developer called dev1 requests access to the server, Linux administrator creates a Linux user for them with name dev1. Similarly, a unique user for dev2, QE1, QE2 for n number of people that would request access to the server. And this process of creating users, creating groups, and managing users and groups is called as user management. Perfect. So Abhishek, I understood what is user management, but why file permissions is required on a Linux server? If you take the same example, so on a Linux server, there are multiple users. And what if all the users on the Linux server has access to all the files and folders on the Linux server? That is, dev1 user has access to all the files and folders created by default, created by other users. Similarly, QE1 has access to all the files and folders by default and created by dev1. This is going to be a huge problem. Why? What if a user deletes important folder like /etc or /sbin? This is going to corrupt the entire file system. Not only important folders. Imagine a user called developer, and this user creates a script in /tmp folder, maybe a script for automating their day-to-day activities, and accidentally a user called QE gets to the tmp folder and deletes the file that is created by the developer or script that is created by the developer. Now this would impact day-to-day productivity of the user called developer. In any of these cases, either corrupting the file system or deleting or updating the files that are created by other users, it is a problem to the user management feature of Linux, right? User management is a very good feature. But what if one user is messing up the files of the other user, or a user is deleting the important files from the file system? There is no point of user management. So to solve this problem, Linux came up with a concept called file permissions. So file permissions is a feature that complements user management of Linux. And file permissions is out of the box. You don't have to install any libraries or you don't have to install anything. It comes out of the box. And what Linux does out of the box, it sets up basic file permissions on all the files and folders. So whenever you create a file, Linux automatically sets up file permissions on that file or even on the folder. However, this is a very basic thing. So Linux creates same file permissions on all the files and all the folders. If you want to modify it according to your organization requirement, or maybe according to your personal requirement, then you need to know how the file permissions work in Linux. And Linux offers some commands like chmod, chown, using which you can change the default file permissions. So understand this carefully. By default, Linux provides permissions on each and every file, or Linux configures file permissions on every file and folder. If you want to modify it according to your requirements, you can use commands like chown and chmod. So this is an important thing that Linux supports to complement the user management feature. Abhishek, can we see how Linux sets up the default file permissions? We can definitely see that. So for that, I will create two users, a user called developer, a user called QE. Using the developer user within /tmp folder, I will create a script file. Then I will show you if I log in as QE user, I cannot update this file. I cannot delete this file as well, right? All that I can do is as a QE user, I can only read the file. So one user by default can read the files that are created by other users, but cannot update or delete the files. Once we understand this, then I will show you how you can modify it maybe as a QE user. As per your organizational requirement, you should not be even able to read the file. I will show you how to modify that file permissions as well. First, let's understand this through the example, right? So I will take my Linux terminal. So I'm connected to a Linux container environment. In the previous lectures, I explained you how to create a Linux container environment. If you haven't followed, you can go to episode 1 or you can go to this documentation. Look at setup.mt. However, if you're not interested in a container environment, you can use EC2 instance, you can use WSL, Oracle VirtualBox. In any of these things, the concept remains the same because they are just things to connect to your Linux server or a Linux virtual environment. Okay. So first thing, I need to create two users. User one is developer. How do we create users? Add user developer. Let me set up a password and I will leave the details as blank because it's not important for today's video. Great. Similarly, I will set up another user called QE. I'll set up a password. Again, I leave the details as blank because it's not important for today's video. Now let's verify if both the users are created. How do you do that? Cat /etc pawswd. If you're thinking I'm going fast, we learned this multiple times in the previous videos. We have done practicals as well. That's why I'm going little fast with these commands. So when I do this, you will notice that, okay, developer user is created, QE user is also created. Perfect. Now, I have two different tabs. In one of the tab, I will switch the user to developer. And in another tab, I will switch the user to QE, right? That means in this tab, I'm connected to the Linux container environment as developer user. And in this tab, I'm connected to the Linux container environment using the QE user. It's very simple. You can go to your terminal, click on shell, click on new tab, and a new tab is created. Most of the terminals support this. If it doesn't support, you can take two different terminals. Okay. Now, using the developer user, I will get into the TMP folder. And here I will create a script called hello-world.sh. Let's write within the script insert mode shebang bin bash. I'll write a very simple hello world. It doesn't matter if you are writing a shell script, Python, or text file because the concept is same. And I'll save the file using escape colon WQ exclamatory. Okay, let's verify if the file is created. Hello world.sh is created. Perfect. Now let's go to the Q user. I'll go to TMP folder. Can I see the file? Okay, I see the file called hello world.sh. Can I read the file? Cat hello world.sh. Perfect. I'm able to read the file as I explained during the theory part. Now let me see if I can update the script file. Ideally, I should not be able to do it because developer created the script. Developer knows the script. As a QA engineer, my knowledge to script is very limited, and because that's the script of someone else, I should not be able to update it. Okay, so enter a new line. Let me write some random string and I will try to save the file. Instantly, Linux file system or operating system throws an error saying can't open the file for writing. That means as a Q user, you cannot update the file. If I still do cat hello world.sh, you will see the same thing, echo hello world. Okay, let me try to delete this file. rm hello world.sh. It is asking, are you sure you want to remove a file? Let me say yes. Then it throws an error, operation not permitted. So this proves that Linux by default comes with file permissions, or there are default file permissions that is set up by Linux on every file and folder that is created. If you want, you can modify it. Abhishek, how can I modify it? That is, now let's say as a QA user, okay, I should not be able to read the file as well. Till now, if I do cat hello world.sh, I am able to read the file. Now, can I change this? Absolutely. There is a command called chmod. Don't worry, I will explain it very clearly, but just I'm trying to show it through the demo now. Then we will learn the permissions, what exactly is the command that I'm executing. Just see what is happening now. So what I'll just say is chmod o is equals to followed by what was the name of the file? Hello world.sh. Now when I go to the other user and if I do cat hello world.sh, it says permissions denied. So with one command, I changed permissions on the file, the permissions that are set up by the Linux file system. Cool. So this proves Linux sets up basic file permissions, and as users, we can modify the permissions on the files. Now, how exactly it works, right? Abhishek, I need to understand how the file permissions on the Linux environment work. If we go back to the terminal and if I do ls-ltr, till now we just know that ls-ltr lists the files, and using this command, you can see all the files and folders on this particular environment or in the particular directory. But if you watch carefully, this particular string, all the strings have the first word in common, right? You can see there is a unique pattern rw blank, rw blank, rw blank, rw blank. So this particular word represents file permissions on the files or the folders, right? So this is the one that decides permissions on files and folders on the Linux server. But Abhishek, what exactly is this? If I write this down, so the permissions on the file, on the first file is blank rw blank rw blank followed by r blank blank. So the first character here represents if it is a file or a directory, right? So this is the only directory here. Test is the directory that I already created in TMP. That's why you see instead of blank a character called D. That means if it is a directory, you will see a character called D. Otherwise, you will see blank. So the first character of this word represents if it is a file or a directory. Okay, leave this aside. Then there are 9 different characters. 1, 2, 3, 1, 2, 3, 1, 2, 3. These 9 characters can be split into 3 sets. Set 1, set 2, set 3. And each set represents permissions of different things. So the first set represents the permissions of user. Second set represents the permissions of group. And the third set represents permissions of others. But Abhishek, what is this user, groups, and others? Very simple. User is the one that created the file. In this case, user is developer. So developer created this file called helloworld.sh. So user is developer. Group is nothing but the group that developer user belongs to. In previous episode, I told you the advantages of group. Basically, users are put inside group so that you can control the access at the group level. So basically, bunch of users are put inside a group, or bunch of users make a group. For example, all the developers are put in a group called dev. All the QA engineers are put in a group called QE. Now these permissions are for the group of the developer. That means dev1, dev2, dev2, right? Dev-n, whoever are the developers that are part of this group, along with the user called developer, they get access which is defined here. Now, finally, others are the ones that are, other Linux users on the Linux file system that are not part of the developer group. In our case, QE user is other user because QE user is not part of the developer group. So that's why QE user had less access. But Abhishek, what is this RW hyphen or RW blank, RW blank, and R blank blank? Very simple. The 3 characters in each set represents read, write, execute. These are the 3 actions, right? Read action, write action, execute action. So in each set, you will find read, write, and execute characters. If there is a blank for any of this character, that means that permission is missing. Now, if you try to understand this particular permissions, user that created the file has the read access, write access, but not execute access. Abhishek, what is write? Write is nothing but updating the file or modifying the file. Read is nothing but reading the file. And execute is basically executing the script. In our case, executing the shell script. So the first set here says the user has read access, write access, but missing execute access. Group that the user belongs to has the read access, write access, missing the execute access. And others, that is every other user on the Linux server, has the read access, no write access, and no execute access. What I did, I removed the read access as well. That's why on the helloworld.sh, when you look at other files, QE user, if I go to the QE user and if I do cat, let's say this file called Abhi, right? I'm able to read the contents of Abhi file using QE user. Similarly, I can read the content of Veeramalla file as QE user, but I mean, it's a blank file. I'm able to read it, but When I try to read hello world.sh, it says permissions denied. That is what I did using the chmod command. To demonstrate you how file permissions work, I used the chmod command that removed read access to the QE user as well. That's why on this particular file, you will see blank, blank, blank as the third set. Okay, I'll just repeat this again because this is very, very important to understand. In Linux, there are three parties. One is U, that is user. G is the group that the user belongs to. And O, that is everyone else in the organization. So user is nothing but the one that created the file. Group is basically the group in which user belongs to. If in this group there are 10 users, then all the 10 users get the permissions that is defined to the group. And O is basically others. So there are three parties. That's why on a particular file or folder, you will see 9 characters, 1, 2, 3, 1, 2, 3, 1, 2, 3, where set of 3 defines the permission of user. The second set of 3 defines the permission to the group of the user. And the third set defines the permission to everyone else or every other user on the Linux server. And these 9 characters are represented using RWX, RWX, RWX. If a particular character is missing, let's say X is put as blank, that means this particular permission is missing to the user. Let's say if X is missing on the group and W is also missing, both of them are set to blank. That means group only has R, that is read permissions. Similarly, if it is set to blank, 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 then all the other users cannot read the file, cannot write the file, and cannot execute the file as well. Let's try one example to understand this better. Abhishek, the current permissions on, if you take hello world.sh, it is rw blank. That means the user that created the file also cannot execute the script. Although developer created this file, but developer cannot execute the shell script as well. Let's see if that is real. I am with the developer user. I can confirm that using who am I. Okay. Now, if I try to execute the script using dot slash in Linux is used to execute the script. Dot slash hello world.sh. It says permissions denied. How can we change the permissions to the user called developer? So I will go to the root user, right? Because root user is the administrator. So I'll just go to the root user. Also, I can do it through developer, but let's take the root user. Let's go to TMP folder. And here, for this file called hello world.sh, look at the command that I'm trying to execute. chmod. For which user or for which party I'm trying to change the permissions? I'm trying to change to the user. That is the one that created the file. So that's why I will say u is equals to rwx followed by hello world.sh. Now, if we go back and as developer, if I try to execute hello world.sh, the file is executed. On the terminal, you can see hello world. Let's do it again. chmod u is equals to, that is user, the one that created the file, is equals to rw. This time I'm intentionally skipping x. U is equals to rw hello world.sh. Now let's go back and see hello world.sh. It doesn't work, right? So this is something using which chmod is a command using which you control the permissions on the file. Abhishek, let's try for others. That is, let's try for the QE user. Why not? Chmod, I will say O, This time I'm using O because I'm trying to change the permission for others, not the user, not the group. I'm trying to change it for the others. So O is equals to RWX on hello world.sh. Now let's switch to the QE user. Perfect. Let's go to TMP folder. Great. // hello world.sh. Now QE user is also able to execute the file. Can QE user update the file? VIM hello world.sh hello world from QE. Save it, execute. Perfect. It is changed. Now the output is hello world from QE. That means using file permissions, you can control the permissions of user, group, as well as others. And the command that we use is chmod. Very simple, right? Great. Okay. Abhishek, is there any easy way to do it? Like, you know, U is equals to G is equals to O is equals to, it is a bit confusing. So is there any other way Linux supports? So Linux supports numbering format as well, right? That means what Linux does, so it says R is equals to 4, W is equals to 2, and X is equals to 1. So overall, together, it sums up to 7. Now on the three sets, so if we go back to the previous three sets, RWX, 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 right? Now when you have all of them enabled, it is 7, 7, 7. Imagine if you want to set up read-write permissions to the user, read-write permissions to the group, and read-write permissions to others. In that case, right, what I'm talking about, read write blank, read write blank, read write blank. In that case, you should use chmod. Read plus write is 4 plus 2, so 6, 6, 6, followed by name of the file. Okay, so imagine if I have to provide, there is a file called test file, and this test file should only have read permissions to the user that it created, to the group that the user belongs to, and also for the others. That means I'm talking about read blank blank, read blank blank, and read blank blank. Now, in this case, what should be your chmod command, right? Instead of putting that as chmod U is equals to RWX, comma, G is equals to RWX, comma, O is equals to RWX, followed by name of the file, which is slightly complicated to write. What you can do, chmod 444 name of the file. What does 444 mean? Read, read, read. Abhishek, I want to create a file where everyone has all the access, read access, write access, and also execute access on the file. So there is a script that anybody can read, anybody can write, and anybody can execute. What permission should I set? That means you are talking about RWX, RWX, RWX. So it should be 777. So the command will be chmod 777 file.sh, or just the name of the file. And this means completely open file. All the people in the organization has access to the file. And what will be the least privileges? That is, what can be something where nobody except the user has access to the file. So it can be chmod user just has read access 400 file name. Now this means the user that created the file has the read access. Everyone else has, even the group that user belongs to, has no access on the file, not read, not write, not execute. Similarly, others as well. So overall, using chmod command, you can manage the permissions on the file in two different ways. One, using the alphabets or using the characters. Second is using the numbers. When you use the characters, you use something like u is equals to rwx, comma, g is equals to rw, comma, o is equals to r. This means u gets all the permissions, g gets limited permissions, and others get only the read permission. The equivalent of it is chmod 7, 4 plus 2 plus 1, g 4 plus 2, that is 6, o 4, 764, name of the file. Now you can practice this by taking some examples, right? You can try to do file that everyone has access to, file that no one has access to, file with limited access. So you can play with the chmod command. Now Abhishek, this is for the files. What about the directories? It is exactly same for the directories as well, right? So if you take, we'll go back. We will switch user to QE user here, and we will switch user to developer user here. Okay, I'll go to root, switch user, developer. Okay, so I'm in the developer user, I'm in the QE user. Now, quite obviously, developer user has a home directory. Within this home directory, right? Or to this home directory, let's see if QE user has access to. So cd/home, cd developer. It says permissions denied. So the same thing applies to folders as well. Why? If I go back and if I do ls-ltr, so on the developer user, what is the permissions, right? The permissions is rwx, r blank x, blank blank blank. So the third set here is blank blank blank. That means every other user except the user called developer and the group in which developer is, all the other users, such as the QE user, has no read access, no write access, or no execute access. It is equals to 7, 4 plus 1, 5, 0, right? So the permissions is 750, where everyone else has no access to the home directory of the developer. So whether it is the file, whether it is the folder, concept is same. And this is the default permission that Linux has set up. Imagine your organization has a rule where QE user should have access to the developer folder. What you will do? You will simply change that chmod 7, 5, and if QE user should have all the access, you will just change 7 because it is others, followed by developer. Now, as QE user, you can get into developer folder. You can create a file here as well. For example, touch test. If I go to the developer user, get into developer and ls-ltr, a file called test is created. Perfect. So this is how Linux manage file permissions as well as folder permissions. Concept is exactly same. Now, this is about chmod command. Abhishek, I understood this. What about a command called chown? So chown is nothing but change the ownership of the file or the change the ownership to the folder. Very simple concept. Imagine a user called developer created a file within /tmp. Okay. Now for some reason, this developer don't want to manage the file. Maybe developer is leaving the organization, or maybe developer is not interested in managing that script file in the future. So simply developer user can provide the ownership to the QE user using chown command. Let's see how this works. So as a developer user, cd/tmp, right? And let's create a file touch test.sh. Okay, so ls-ltr touch test.sh created a file called test.sh, and if you see here carefully, the owner of the file is developer and the group that file belongs to is also developer. So these two fields represents owner as well as the group of the owner. By default, it is developer and developer. So this particular field is basically for the developer. Now you can change the ownership of the file using chown qe:/qe on test.sh. Okay, it says changing ownership is not permitted because you are not the root user. To change the permission, you need to be the root user. So for that, I'll just go back. As root user, I'll get into tmp and I will run the same command chown qe:/qe on test.sh. Now if I do ls-ltr, you will notice the ownership of the file has changed. Previously it was developer developer, now it is QE. As simple as that. So to change the ownership of the file, you will use chown, but to manage the permissions on the files and folders, you will use chmod command. Perfect. It comes with practice. Try to do a lot of practice using chmod number format, that is 777, 666, 400. Try to do all of these things on a file and try to see how the permissions change. Along with this, you can also try the alphabetical format. U is equals to, G is equals to, and O is equals to. If you want to set up multiple things using characters at once, you can use the comma. U is equals to rwx, comma, G is equals to rw, comma, O is equals to nothing, followed by name of the file. Because this is complicated, Linux came up with numbering system. Okay, now the final thing. Abhishek, what if there is permissions on folder and there is permissions on the file as well, right? Whenever you create a folder, the folder has permissions and also the file has permissions. Best example is this one, right? If you go back, ls-ltr, tmp has one permissions, or even if I go to home directory and within this home directory, now QE folder, that is the home directory of the QE folder, has some permissions. And if I go to the QE folder, any file that is created on the QE folder also has permissions. For example, touch text. Now this also has permissions. In this case, which permissions apply? So what are the permissions that apply to the test file? Will these permissions apply to the test file, or will the permissions on the QE folder apply to the test file? Because the file test is inside the QE folder. What do I mean to say here? So there is a folder called QE, and within this folder, there is a file called test, right? And this test has some permissions. Let's say rw blank, rw blank, r blank blank. Folder also has some permissions, and these permissions are not the same. Let's say folder has permissions rw blank, r blank blank, blank blank blank. Now, if an external user, or let's say other user, is trying to access this file, now for this user, will this permissions apply or this permissions apply? Very simple. Like, this is an interview question that is asked, and sometimes people get confused. Whenever you see a scenario like this, just imagine a simple example. Imagine there is a bank, and within the bank, there is a locker. Okay. Now you are trying to access the locker. What permissions apply to you? The first permissions that apply to you is permissions to enter the bank, and then permissions to access the locker. Imagine you have permissions to access the locker, but for some reason, your access to bank is denied. Now, you cannot get through the bank. So obviously, you cannot access the locker, right? Similarly, let's say you have access to the bank, but not to the locker. So you can get to the bank, but not the locker. So the bank here is basically folder and locker here is basically the file. Now, whenever somebody asks you, do you have access to a file? The first thing that you need to check if you have access to the folder first. If somebody says there is a file within the /tmp folder with name /tmp/text, the first thing that you need to check if you have access to tmp folder. Only then you will go to the file and verify if you have access to the file. You might have access to the file, but if you don't have access to the folder, there is no point. In short, it's a prerequisite that you need to have access to the folder. Only then, if you have access to the file, it works. So the permissions on the folder takes more priority. Just remember this, bank and the locker. If you want to get to the locker, you should first have access to the bank. Only then you can get to the locker. We will do the final demonstration on this and then we will conclude the session. I would highly request you to follow everything and try out the examples so that you will never forget this concept. So what I'm trying to say here is, so we will go to /tmp, right? First, let's see what is the permissions of /tmp. So what I will do is I will just change the permissions for tmp. So I'll just say chmod 400/tmp. That is, nobody except the root user. Root user is the one that created tmp folder. So except root user, or I will just change to chmod 700. So root should do everything, or root should be capable of doing everything on the tmp folder, but everyone else should have no access on the tmp. Now I'll get into tmp, right? And within tmp, I will create a file touch or vim Abhishek or demo. And within this demo, I'll just write some random things. And for demo, I will grant 777. Okay. Now, what do you think happens? On the demo, the permissions are 777. But if you look at the parent, that is TMP, the permissions are nothing. Now, as a QE user, can I get into TMP? No. If I can't get into TMP, there is no way if I try to do /tmp/demo. There is no way I can access the demo file. This is what I'm trying to explain. You might have permissions to a file, but if you can't get into the folder, there is no way you can access the file. So the permissions on the folder take the highest priority. Bank and the locker. Remember this. I hope you found the video interesting. Also, try to go through this documentation. I've put a lot of effort to write readme.md file. I have explained everything, right? What is owner, what is group, what is the numbering system, and I've added more examples as well, like some examples using the alphabet system, examples using the number system, chmod command, chown command, and multiple other things, few of the things that I might have missed in the video as well. So that's all for today's video. Thank you so much for watching. See you all in the next one. Take care. Bye-bye.